Okay, assessment review over composite functions. First off, f of x equals x plus 5, g of x equals x squared plus 2. Now, if I got to do a bunch of crap with these functions, I want multipliers in front of the x, so 1 and 1. Okay, so f of x is 1x plus 5, g of x is 1x squared plus 2. So let's go with this. F is 1x plus 5 plus the g, 1x squared plus 2. Okay, so I don't have like terms with the x's. I got to keep them separate. And then 5 plus 2 is 7. Oh, sorry, PEMDAS. Went too fast. Parentheses, you can't add in there. Exponents just on the x. Multiplication, no. Division, no. Adding, that's when you add the 5 and the 2. No subtraction. Just put the 3 in then. That gives me 19. Okay, f minus g of x. So the f is 1x plus 5 minus the g, 1x squared plus 2. And then the subtraction, you make it addition, make that negative, make the 2 negative. Okay. Parentheses, and can't do anything. Exponents just on the x. Multiply, no. Divide, no. Adding, yeah, 5 and negative 2. The negative 1x squared and the 1x are separate. And then 5 and negative 2 add up to 3. Okay, then put your 2 in for that expression for x. I got 1. Okay, f divided by g of x. So f is 1x plus 5 divided by the g, which is 1x squared plus 2. And there's nothing we really do on that division. So I just insert negative 4 into the top. And if you insert that in, you get 1. And the bottom is 18. I'll just prove it to you. So 1/18 is your answer. Okay, f, input, g of x. So I start with the f, and that's 1x plus 5. Get him out. And I insert the g, 1x squared plus 2. Okay, so PEMDAS, parentheses, you can't add those. Exponent just on the x. Multiply 1x squared plus 2 plus the 5. No division. Adding 2 plus 5 is 7. 1x squared plus 7. So now I put the 5 into that. So 1 times 5 to the second plus 7 is 32. Okay, next one, another input. Okay, so we start with our g function, 1x squared plus 2. Get your x out. Move your second power, and then you're going to put 1x plus 5. And we got the plus 2 there. So x has been removed. Okay, so on PEMDAS, okay, parentheses, can't do anything there. Exponent, yeah, and then it's more than just the x, so we got to take the whole expression. So I need to take 1x plus 5 times 1x plus 5. Okay, so 1x times 1x, 1x times 5, 5 times 1x, and 5 times 5. This is going to be 1x squared, 5x, 5x, and 25. That gives me 10x. So 1x squared plus 10x plus 25. Now, back to the paper. Drop your 1. Now we make a parentheses without the power. but then you got to put something new in the parentheses, and you put 1x squared plus 10x plus 25. Now the exponent's done. Now it's time to multiply. And plus 2. Adding 25 and 2 is 27. Okay. Now insert your negative 2 in there. So 1 times negative 2 plus 10 times, 1 negative 2 to the second plus 10 times negative 2 plus 27 gives me 11. Okay, now find the two functions composed together that would have made this when I composed them, when I did the input. So x minus 3 is kind of the isolated structure. Then I have a 4 parentheses to the second plus 6. But instead of x minus 3, I just put x, because x would pop out. That would take its place. Okay, absolute value of x minus 3, so x minus 3. And then I have an absolute value. Instead of x minus 3, I just put x. Okay, find the inverse function of y equals 8x minus 3. So flip those. So it's going to be x equals 8y minus 3. And now get the y by itself. So I plus 3 plus 3. So x plus 3 equals 8y. Divide by 8. Divide by 8, and we're there. So y, x plus 3, all divided by 8. Okay, next one, flip them. Box your y up, so I'm minus 7 from that, so x minus 7 equals 2y squared. Okay, now divide by the 2, get that out, so x minus 7 over 2 equals y to the second, and for y to the second I do the square root. Cancel there, and now I have the square root of x minus 7 divided by 2. Okay, next one. Stores selling very expensive items one a day in March sell any item for $20 less than the listed price. On any day in March, the store will give a discount of 15% to any customer who can prove that he or she contributed to a local charity. Compose an equation for $50 off our unknown price, x dollars. $50 off is x minus 50. Okay, now with the percent, we got a times by the difference of 115%. So it's going to be 85%. So it's going to be 0.85. That's going to be what I multiply that by. So it's going to be 0.85x. So to compose, this is going to be my f of x. Put a 1 in front so you have a multiplier. And that's going to be our g of x. Remember, when we have to compose functions, I would like multipliers. Okay, so to compose, the x has to have go through the $50 off process first, and that would be the f. So put that closer, and then it gets to the 15% off. And then here we just reverse them. Okay, 15% off, x has to go through the g function before it gets to the f. Okay, so g is 0.85x, 0.85, get the x out, replace it with our 1x minus 50. Okay, so multiply 0.85x minus 42.5 is what that is. And then turn it around, the f function first. And then replace your x with 0.85x. Okay, just one multiplication there, so 0.85x minus 50. Okay, if an item costs $675, calculate the cost from each composition. So we have this equation here. We're going to put in 675 minus 42.5. And then we're going to take the other one, 0.85 times 675 minus 50. Okay, it gives me $531.25. Gives me $523.75.